Hey guys, welcome to my video on unit testing with Rust. So if you've been doing Rust for a while, you've probably seen that doing unit tests is extremely difficult with Rust. A lot of projects are actually not doing unit tests at all because of the difficulty, and they're just doing integration tests. So in this video, I'm going to show you how to do true mocked and stubbed unit tests where only the unit under test is actually running and everything else is mocked out. So let's get started. Okay, so I'm going to show you how I did this by showing you one of the projects that I'm currently working on. So this is an Actix web server, and I'm using SQLX to connect to a Postgres backend. And if we start at the top here, you notice that I have this module called private members. So the reason why I'm creating a module inside of this file is because I want to hide from the rest of my crate the specific calls that I'm making, the functions that I've created to access the database. Now I'm going to explain, as related to the unit test, why I needed to do this. But let me just kind of quickly go over what this gets us. So in the case of Rust, it has modules that are somewhat similar to modules in ES6, where they allow you to containerize or logically separate out certain pieces of code. Now, the interesting thing about Rust is that the modules are not just code, but modules can be let's see here. So modules can be folders. Modules can be files, as you can see here. And then modules can also be just code, straight up code, which is a lot like the namespace keyword inside of TypeScript. So by creating this non-public, right, because I didn't use the pub keyword, but by creating this non-public module, I'm able to create code that is only accessible to the parent module. In this case, it's repo.rs, the file, but it is not exposed to the rest of the crate. So in other words, the rest of the crate cannot get access to the members that are in here because they don't have access to the module itself. So just super quickly, I'm not going to get into SQLX in this video. This video is specific to the unit tests themselves. So, but really quickly, just to explain what these things are doing, insert message is doing a SQL statement to create a new message entity into the database and just getting back the ID. And then here, I'm basically doing the same thing, but I'm doing it as a response to a message. And then over here, I'm able to query messages that I've already inserted into the database. So that's what's in the module. Now, this is kind of the meat or the heart of this design pattern that I came up with. So normally what you would have in most setups, certainly for like a repo instance type, is you're going to have a single monolithic trait, right? And then you're going to have all your members defined in that one trait. And then the type, the struct, the enum, whatever it is, it's going to, impl that one monolithic trait, right? But in this case, as you can obviously see, I have every single one of my calls, insert a message, insert a response message, query the message. They're all separately in their own trait. And then they're all implemented separately, right? Now, I'm going to show you, what the logic behind that is, but super quickly, you can see that the implementation, as I said before, is making use of the internal module, the module local to this repo.rs file, which is also a module, and then it's able to access the inner functions that I created without actually exposing the real implementations out to the rest of the crate, right? So we're doing that just, super repetitively in all three trait implementations. And then the reason why we need to do it this way is because we want to be able to mock every single call individually as needed. But if we have a single trait and a single monolithic implementation, then we're having access to everything in a specific way all at once without being able to selectively, okay, in the case of insert response message, I want the actual real call, right? But in the case of insert message and in the case of query message, I want to mock it out, right? So by having these traits separated out, or having these calls separated out into their own trait, that enables us to do that. So now we're going to get to the heart of how I'm implementing these decoupled traits to be able to do mocking and all that stuff in my unit test. So we have our standard, classic module that represents all of the tests, all of the unit tests that we're going to run. And then in my case, I'm creating certain fixtures and certain setups that I want to do before running my actual tests. So this is pretty, obvious stuff. I need a connection to my database, obviously. In my case, I want to mock out a profile. In other words, I want to not run the code, the actual code for whatever it is that's generating the profile. I want to mock that out. And it's the same thing for a certain message that I'm responding to. I want to mock that out as well. So I put that into the fixtures as, fixed data that I'm going to be using. So this function, which is represented by a trait, is just setting all of that stuff up and hard coding it into my one fixture. And then in the case of the actual running of my test code, the way that I have it set up is I have a child module per test. So in this case, I want to insert a response message. So I've created a separate dedicated module to do that. And the reason why I did that is because each of my tests are going to have their own mocks, and they're going to be running their own unit under test that might be different from other tests, right? So the mocks that I'm creating are distinct for every single test that I'm running. In some cases, I won't need any mocks because the code that I'm running is super simple. I just make the call that I'm supposed to be testing, and that's basically the end of it. But in certain cases, you're going to obviously need to create certain other entities beforehand before you can create the one entity that you want to test, which is the case for this particular call. So I create a brand new struct that's going to be implementing those traits that I was showing you. So one trait per call, right? So this guy is going to be implementing those calls. He just has extra members in here just so he can have access to the fixtures. And then this implementation just gets us the already created setup function, right? So all this guy has to do is just call that setup and get all of the fixtures automatically set up. And then this is the actual implementation of the calls that I need to make. So as I was saying before, when it comes to the unit under test, I want to use the actual real live code implementation, right? Once again, we go into the private members module, we get access to that inner call. In this case, it's insert response. In your case, it'll be something else. So then I implement insert response message FN, which represents that one specific call. So we know that this is going to do the real, production live code. And then in the case of the other stuff, we're going to do our mocks. So we have our implementation, but instead of actually calling into the real code, we're just calling into the fixture, which I'll show you the setup in a moment. But so the fixture was set up, so the values are all in there. We clone it so that we can use it again. And then in here, we return the specific ID, which again is original message ID, because we're creating the original message that we're responding to. So we're mocking that out, right? Because we don't want to test the other stuff that is related, but we don't want that to be in our test because then that would not be a unit test, right? So then in the case of the profile, which is what is needed both by the response message and the responding message, right? We're just going to create, we're going to implement the insert profile function. And again, we're going to mock it out and we're just going to return that one profile ID that was in the fixtures. And then we have our actual test right here. And we take our testing struct or testing repo instance, as you can see by the suffix of the name, and then we instantiate it. We run our setup. That gives us our fixtures. We clone it out so it's this guy gets a unique one. And then we're able to make the mocked calls, right? So again, this is not actually hitting the database. This is going straight into the fixture, getting that hard-coded value for the profile ID, and then it's returning it out. Then I take that profile ID, I create the parent response object, right? The one that our unit under test call is actually trying to respond to. So once again, this call is completely mocked out. It never hits the database. It's going to the fixtures and getting that hard-coded value. And then in this case, let me just close this out. In this case, we have our original message ID. So this call is responding to the original message ID and creating a new response message pointing to that original message. Just for testing purposes, I'm just pretending that I'm responding to my own message. So it's the same profile ID. And then, of course, this is the database connection. And then this is the body of the actual message. So we assert that when the response comes back, because the response returns an ID of the entity that was put into the database, that it's a number greater than 0 because I'm using integers as primary keys. And then if I run the test, let me make this a little bigger. So if I run the test, and these are the integration tests that I'm also running separately in the standard test folder. But you can see right here, we have our test module right here. And then we have our actual test itself. And then it passed successfully. Okay, so that's it. As you saw, pretty easy to set up and gives you true mocking ability in all your unit tests. So that was it. Thanks for watching.